The examples in this video go with section 10.3, the parabola. Example 1. Given a parabola defined by x squared is equal to 4y, find the focus and an equation of the directrix. Okay, let's back up to the previous slide. All right, the focus, you can see, is defined to be the point 0 and P, but how do we get to P? All right, P is actually the coefficient on y, 4 times P and then times y. So what we're going to do is we're going to solve the equation 4P is equal to whatever our coefficient is on y in that equation. In this case, that's 4. So we're going to solve the equation 4P is equal to 4. And that gives us P is equal to 1. All right, now according to my formulas over here, once I know P, I know that the focus is located at 0 and P. So in our case, our focus is going to be located at 0 and positive 1. And now the directrix, the equation for it right here, y is equal to the opposite of P. And in our case, y will be equal to negative 1. And there we have them. Example 2, given x squared is equal to negative 8y. Part A, identify the vertex, focus, and focal diameter. Part B, identify the endpoints of the lattice rectum and graph the parabola. And Part C, write equations for the directrix and the axis of symmetry. All right, the x squared is equal to 8y. First of all, we know that this one is going to be opening up or down, just because we know that the x is our squared term and the y is our linear term. Okay, that's important. So, and in fact, this one is going to be opening down, and we know that because of the negative sign right here. Okay, our vertex is going to be at 0, 0, and we know that because there's nothing here grouped with the x, and there's nothing over here grouped with the y being added or subtracted to it. So we have our vertex here at 0, 0. Okay, the focus, remember, in order to get to the focus, we have to solve the equation 4P is equal to that coefficient on y. So in this case, that's going to be the negative 8. And when we divide by 4, we find out that P is equal to negative 2. That makes the focus at 0 and negative 2. I'm just going to put it right here. Now your parabola is going to open in the direction of the focus. The focus should always be in the interior of your parabola there. All right, the focal diameter. We haven't really talked about this a whole lot. It's not really obvious in the notes there, but your focal diameter, I'm just going to put FD here. This is going to be 4 times the absolute value of whatever P is. So in our case, we're going to have 4 times the absolute value of negative 2, which is going to give me a positive 8. So I know the focal diameter is 8. In other words, the parabola is going to be 8 units wide right here across the focus. We should know that there's 8 units from side to side across the focus there. Okay, part B. Now we want to identify the endpoints of the lattice rectum. That's going to be the little line that goes through the focus, okay? And then we're going to graph this thing. Now, easily we can just say, oh, we've got 8 here. Let's just add 4 to this side. And there is one endpoint. And then we can subtract 4 from this side. And there's the other endpoint. And then I can just kind of sketch my parabola in this way right here. And now we have a nice pretty sketch. The way we should probably get those endpoints, though, is we want to take the vertex, not the vertex, I'm sorry, the focus here, okay, and we are going to subtract half of that focal diameter, so 8 divided by 2, and then we're going to keep the y coordinate. And then for the other one, we're going to add half of that focal diameter, and again, we're going to keep the y coordinate. So that makes our endpoints be -4, because 8 divided by 2 is 4, and 0 minus 4 is -4. So -4, -2, and also 8 divided by 2 is 4, 4 plus 0 is 4, so we got +4, -2. And those are going to be the endpoints. And those are the ones that I've graphed right here. All right. Part C, write equations for the directrix and for the axis of symmetry. The axis of symmetry, we've done this one a whole lot before. Since this one is a parabola that opens down, this is going to be x equals, and remember the axis of symmetry goes right through the vertex. And this line right here that I've drawn in as a dotted line is the line x is equal to 0, because that's what the x coordinate is for the vertex. The directrix, we've done this once before. We said that was going to be y is equal to -p. All right, so in our case, y is going to be equal to -2. In other words, y is equal to +2, which will put it right up here. And you'll know that you have the correct equation for the directrix if the distance from the directrix to the vertex is the same as the distance from the vertex to the focus. They should be equidistant away from the vertex there. And that's how we have everything we need. Example 3, given -2y squared is equal to 24x, part A, identify the vertex, focus, and focal diameter. All right, let's take this and let's actually get y squared by itself first of all, so that we can get this parabola in its standard form. This is going to give me y squared is equal to -12x. All right, now, this time we have a y squared. And what I know about when the y is the squared term and not the x, these are the ones that open up to the left and to the right. Okay, this one in particular is going to open up to the left, and I know this because we've got the negative sign right over here. All right, the things that we need to find. All right, first of all, we want the vertex. Well, this one's going to be pretty quick. The vertex, again, is going to be at 0, 0. And I know this because there's nothing grouped over here adding and subtracted to the y. There's nothing grouped over here added and subtracted to the x. So here's our vertex. The focus, we still want to figure out what p is. All right, so we're going to solve the equation. 4p is equal to, this time, we're going to look at the coefficient on x. So 4p is equal to -12. When we divide by 4, we get p equal to -3. Okay, now, since the direction of this one's going to change, because now we're looking at one that opens left and right rather than one that opens up and down, let's see what we're going to do with the p. For the focus, p is going to go in the x coordinate, and then 0 will be for the y coordinate. Okay, so for us, the focus will be at, sorry, wrong one. The focus will be located at -3 and 0, which will put it right here. And we also want to have the focal diameter. Okay, now remember, the focal diameter we said was going to be 4 times the absolute value of p. And in this case, that's going to be 4 times the absolute value of -3, which is going to give me 12. Part B, identify the endpoint to the lattice rectum. Okay, that's just the line that goes through our focus. Well, remember, we can just count this. Half of 12 is 6. We can actually go up 6. And we can also go down 6. And now we have the endpoints for our lattice rectum here. And actually, we can just go ahead and sketch the parabola in. Make sure you're nice and curvy back here, though. We don't want any V-looking parabolas. And we have something that looks kind of like that right there. And these endpoints, again, we're going to, let's see, we're going to keep the x this time, which is -3. But the y, we're going to subtract, or we're going to add half of that 12, or -12. And we're also going to subtract half of that -12. And this will give me the point -3. Let's see, -12/2 is -6. 0 plus -6 is -6. That's this point right here. The other end point, we got -3. -12/2 is -6. 0 minus -6 is going to give me a +6. And that is this point right here. So we actually have our endpoints right there. Part C, write equations for the directrix and the axis of symmetry. Remember I told you the thing about the directrix is it should be located exactly the same number of units away from the vertex as the focus. And the distance from our focus to the vertex here is 3, which means that the distance from the vertex to the directrix should also be 3. And this line right here is the one that we're looking for. And its equation is x is equal to +3. Now the axis of symmetry, since this parabola is opening up to the left, the axis of symmetry is actually going to be a y equals equation, because remember we're looking for the line that goes through the vertex. Here it is. This is the line that goes through the vertex of the parabola, and the equation of this line is y is equal to 0. Example 4, given the quantity y minus 2 squared is equal to -8 times the quantity x minus 4, part A, identify the vertex, the focus, and the focal diameter. Okay, the vertex is actually going to change on this particular problem, and that's because I now have things that are grouped with my y, and I also have things that are grouped with my x. Now, the short and quick way to figure out what your vertex is to take a look at each parentheses, figure out what gives you 0, and that gives you the coordinates. So if I fill a +4 in right here, 4 minus 4 is 0, I know part of my vertex is +4. If I fill a 2 in right here, 2 minus 2 is 0, so that means 2 is the other coordinate. And since I put the 4 in for x, that's my x coordinate, and the 2 went in for my y, so that's my y coordinate. So my vertex is going to be at +4 and +2, which puts it right here. All right, the focus, we're still going to start off the same way. We've got to figure out what P is. So we're going to set 4P equal to -8, and we'll divide this by 4. This tells me that P is actually equal to -2. Okay, let's go to our sheet here. The y term is the one that was squared, so that means we have a parabola that's going to be opening actually to the left, and that's because we had the -8 right here, so we know this guy's going to be opening up to the left. We figured out what our P is. The focus is the x coordinate plus P and then K. All right, so our focus is going to be our x coordinate plus P, and then we get to keep K. Now 4 plus -2, that's just going to give me 2, and then of course y was equal to 2. So it looks like my focus is going to be right here at +2, +2. The focal diameter, this is just going to be 4 times the absolute value of P, in our case 4 times the absolute value of -2. That's going to give me 8. Part B, what are those endpoints then? Well, let's see. Remember, the quick way, if we have the graph, is we go to the focus, we can split that 8 in half, and we can move up 4, and we can move down 4, and then we can sketch our parabola in from there, kind of like this. And then those endpoints, which we've already graphed, let's see if we can figure that out. Let's see. We are going to keep the x coordinate of the focus, which was positive 2, and then we are going to take the y coordinate and we're going to subtract half of that focal diameter, and we're also going to take that y coordinate and we're going to add half of that focal diameter. So that's going to give us positive 2 and negative 2. That's this point right here. And it's going to give us positive 2 and positive 6. And that is this point right up here. All right. The equations for the directrix and the axis of symmetry. We can do the directrix first. Actually, it doesn't really matter. The distance from the focus to the vertex is 2 units. That means the distance from the vertex to the directrix should also be 2 units. And so this line right here is the one that will be the directrix. And the equation for this line is x is equal to 6. The axis of symmetry, remember we want to go right through that vertex, so that's going to be this line right here. And the axis of symmetry is y is equal to 2. Example 5, given the equation of the parabola 4x squared minus 12x minus 12y plus 21 is equal to 0, part A, write an equation in standard form. All right, let's move on to the next slide. And what I've done is I've rewritten my parabola equation right here. We need to put it in standard form. That means we're going to have to complete the square. Now, I only have to complete the square on x because x is the term that is squared. I don't have a y squared term in here. So what I'm going to do is I'm going to take this 12y and the 21, and I'm actually going to move them over to the other side of the equation just for a moment. Actually, they need to be on the other side anyway for it to be in standard form. This is going to leave us with 4x squared minus 12x equal to 12y minus 21. Okay. Now, to complete the square, remember, this first coefficient has to be a 1, and it's not, so let's factor that 4 out. This is going to leave me with x squared minus 3x equal to 12y minus 21. Okay. Now we're going to complete the square because there is something that I want to add over here on this side, and I want to be sure and add that exact same thing over here on the other side. So let's see, we're going to take half of that negative 3, and then we're going to square it. And this is going to give me .25. So I'm going to add 2.25 to this side, and to the other side I'm going to add 4 times 2.25. And the reason is because of this 4 out here outside of the parentheses. Okay, over here on the left, we know that's going to factor. It actually factors into x minus 1.5 times x minus 1.5. Well, we can write that as x minus 1.5 squared. And then we'll have 12y. And let's see, 2.25 times 4 minus 21 is going to give us negative 12. So we actually have 12y minus 12 on this side. Okay? All right. Notice in our equations up here, neither one of my squared terms had a coefficient out in the front here. So what I'm going to do next is I'm actually going to divide that 4 away so that there's no coefficient out here in front of my squared term. I'm going to divide here, and we're going to divide here. That's going to leave me with x minus 1.5 squared equal to 3y minus 3. And I'm actually going to go one further because I'm going to factor that 3 out so that it is in standard form there. All right. So here is my standard form equation. X minus 1.5 squared is equal to 3 times y minus 1. All right, part A is taken care of. Now, part B, where's the vertex? Well, the vertex is going to be located at positive 1.5 and positive 1. Remember, it's whatever I can fill in to each of the parentheses to get 0. All right, positive 1.5, that's going to be 1.5, and then up 1. So my vertex is going to be right here in the middle between 1 and 2. Okay. The focus, well, let's see, 4p is going to be equal to that coefficient out in front of y. In this case, that's a 3. That means our p is going to be equal to 3/4. Okay, so our focus is going to be keep the x coordinate of your vertex and then add p to the y coordinate. So keep x and then add p to y. So we're going to keep x of 1.5, and then the y coordinate is going to have 3/4 added to it. That means our focus is going to be located at 1.5 and 1.75, which is going to put it right up in here, approaching 2, but not quite there yet. Okay, the focal diameter is going to be 4 times the absolute value of 3/4. This is going to give us 12/4, which just reduces to 3, so our focal diameter is going to be 3. And then it's asking me to graph the parabola. Now this time it did not ask me to find the endpoints of that latus rectum, and it didn't ask me to find the directrix or the axis of symmetry. So what I'm going to do is I'm going to go to my focus, and I'm going to move 1.5 to the right. So there's a half. There's 1. We'll put this point right here. Remember, this is just below 2. And then we want to move 1.5 to the left. So that's going to put this point right here, just below the 2 again. And we can graph this guy, and it will look kind of like this right here. And there's our parabola. Example 6. Determine the standard form equation of a parabola with focus -2, +3, and directrix y equals 7. Okay, let's graph the stuff that we have. Now, it doesn't ask us to graph it, but sometimes it helps to see a picture of what we actually have. Okay, so -2, +3 is going to put our focus right here. The directrix is at y is equal to 7. So you got 1, 2, 3, 4, 5, 6, 7. So we're looking at this line right here. Now, what this tells me is that our parabola is actually going to be opening down. And I know this because remember I told you the focus has to be in the interior of the parabola. And the directrix, of course, is going to be behind the parabola. So we've got that taken care of. Now, we can find the vertex pretty quickly. Remember what I said, the vertex is supposed to be exactly halfway in between the focus and the directrix. So the total distance from directrix to focus is 1, 2, 3, it's 4 units. So that means that To get to the vertex, we should go 2 units, and then to get from the vertex to the focus should be 2 more units, which would put my vertex right here at the point -2, +5. All right, so our parabola is going to do something along these lines right here. Okay, so now that we know that it's going to be opening down, we want the equation to look like this one right here. X minus h squared is equal to 4py times y minus k. Actually, it should be 4p times y minus k, shouldn't it? Yeah, 4p times y minus k. Oops. Let's try this again. All right, so that means right now I have x plus 2 squared is equal to 4p times y minus 5. Now I just need to figure out what p is equal to, and I will know what this coefficient is, and I'll have the equation that I need. Okay, the focus formula, and here it is. It's going to be h and then k plus p. All right, that's important. This is h, and this is at k plus p. Now, we also know that the focus has been given to us as being -2 and +3. And we know that k, we just figured that out, was going to be 5. So really we can write this as h and 5 plus p. All right, now something that we know that h is equal to -2, right? That means that 5 plus p should be equal to this +3 right here. And if we subtract 5, that tells me that p is going to be equal to -2, which makes sense because remember our parabola is opening down and we want our p to be negative. Okay, so all I need to do is put my -2 in right here for p. That's going to give me x plus 2 squared equal to, let's see, 4 times -2, that's going to give me -8. And then y minus 5. And here we go. There's the equation for my parabola. Example 7. A radio telescope is in the shape of a paraboloid. Cross sections taken parallel to the direction the telescope opens are parabolic. Cross sections taken perpendicular to the direction the telescope opens are circular. The diameter of the telescope is 70 meters and the depth is 14 meters. Part A, find an equation of a parabolic cross-section through the vertex of the telescope. Part B, where should the receiver be placed? Okay, so over here on this slide, I have written down the information that we know. First of all, we know that the diameter of our paraboloid is 70, and we also know the depth of it is 14. So if we draw a little cross-section of it right here, okay, we know that this distance right here is 14. The depth is going to be 14, okay? We also know that this would be an endpoint, this would be an endpoint, which puts our lattice rectum going right here. That makes this point, let's see, if the whole thing is 70, then we've got a point here at 14 and +35, and then we've got a point down here at +14 and -35. And all of this is assuming that our center is right here at 0, 0. Okay, so since we know that this equation is going to be opening to the right, we're going to be looking for this format right here. Actually, though, not even that one, because we are going to put the center at 0, 0. So the format we're looking for is this one right here. Y squared is equal to 4 times P times X. All right. So this is the form of the equation we're going to be looking for. Now, I already have 3 points that are located on this. Now, I can't use 0, 0 because we knew that one was the center there, but I can use either one of these two to help me figure out what P is. So I'm just going to use the first one there. We'll fill in the 35 for Y. P is what we're looking for, and I'll fill in that 14 for X. All right, and we'll put this in the calculator. 35 squared gives me 1225. And on the other side, 4 times 14 is going to give me 56. And if I'm looking for P, I'm just going to divide that 56 out of there. And P, it turns out, is 21.875. So for part A, the standard form equation we're looking for is y squared is equal to 4 times 21.875 times x, or y squared is equal to 87.5x. All right, so there's our answer for A. There's our equation. All right, let's go back and look at part B. Where should the receiver be placed? In other words, it's asking us, where is the focus? And we can figure this out, remember, by taking 4P and setting it equal to the coefficient right here, 87.5, but we already know how that's going to work out because we just multiplied those earlier. So we know that P is going to be equal to 21.875. Okay, so what that tells me is that my focus is going to be located right here on this line. Remember, it's located between the two endpoints of my latus rectum. And so that means that receiver should be put at 21.875, or in 0. And here we go.